Hi everyone, just a quick message before I start my video. Quite a number of you have said there are audio quality issues, particularly when I use my camcorder. It has a built-in microphone, it's quite poor. Basically the solution is to buy a new camera, but a new camera is very expensive, so I've created a GoFundMe campaign. The link will be in the description. If you want to donate, cool. If not, don't worry. But I thought I'd let you know. Thanks, bye. Hi everyone and welcome to this video. In this video I'm going to talk about relays, and in particular this one. So this is a little Songle relay, and I'm going to show you how to wire it up to an ESP32, an Arduino and an ESP8266. But to be honest, I'm just going to wire it up with this one because the process is more or less the same anyway, and the programming is the same, so yeah, it doesn't really matter. This method will work on all three. So anyway, what is a relay and why would we want to use it? Well, this relay is basically, well, any relay is basically a switch, and sometimes switches have two poles, so it's either switched to one or it's switched to another, and it has a common as well. So yeah, in this case this is the common, and then there are two options, if you like, which can be switched to. So it's like it can either short those two together or it can short those two together. And these two here are for the coil, and when you power the coil it switches one way, when you don't power the coil it switches the other way. So yeah, it's a pretty cool little switch basically. So why would you want to use it? Well, you could use it for a couple of different reasons, but the main ones are, or the main good things about these relays are, that the control circuit, if you like, is separate from the switching circuit. In other words, in this here, there are actually two circuits, if you like, and the 5-volt coil circuit is not connected to the switching circuit at all. In other words, if I was to power this thing with an ESP32, the switch that it operates is not connected electrically to this module at all, or this board. It's not connected. So what it means is basically that I could have a high power AC circuit being switched here, but only have a 5-volt control circuit here. And with them not being connected electrically, I can feel safe that my ESP32 is not going to be well, damaged, if you like. So yeah, it separates two separate circuits, which is ideal in some situations. Now the other thing is it allows you to switch different voltages. So even though this thing here is 3.3 volts, I can actually switch something that's 250 volts, or 50 volts, or 200 volts, or 48 volts, 32 volts, 12 volts, whatever, it doesn't matter. And also using this thing here, the relay, I can also switch via this a circuit which is 10 amps. And this would never be able to cope with that. So yeah, via this, using the relay, I can have a great deal of flexibility in switching things on or off. Anyway, now I'm going to have a play about with it. So I've got a 5-volt power source here, and you can see the two leads. In fact, I'm going to zoom out a bit. So you can see the 5 volts, and when I power this, you should hear a click. So again, the coil, it doesn't matter, there's no polarity to the coil. So as soon as I do it, you should hear a click. Ready? Well, the whole point of showing you this is that you could use it in your circuit. But it's not quite so simple, because there are two little issues which you need to work around before you can actually use it. With your microcontroller anyway. If I put this into amp mode, where's amp mode? There it is. I should be able to show you. Let's go to 200 milliamps. So this is the first thing. To make this relay work, you'd have to power the coil, wouldn't you? But the ESP32 and the Arduino and all that sort of stuff, usually they recommend the maximum amount of current of 20 milliamps, usually. But if you see what happens here, I'll connect it up. And power the coil, but I'm going to hold this on here so we can run it through the ammeter so you can see how many amps it actually draws. So if I just connect this one here, There we go. And look how much it's drawing. 66 milliamps. And that's way too much for Arduino, ESP32, etc. So because it draws 66 milliamps, well, what can we do? Well, there are two main things you can do. The first one is you could apply a resistor, and if you applied a resistor, it wouldn't draw so much current. But at the same time, you could have another issue that it's slow to switch on and off. So I'm not going to go down that route, but that would be fine, you could do that. Or the other route is to use a transistor, which can handle 66 milliamps. And ideally, really, you could probably use both methods. Anyway, I'm going to show you the transistor method. So just to reiterate, the microcontroller is not really designed to power the coil or the switcher, if you like, the control circuit of the relay. So we need to get around that problem. So to get around the problem, we use a transistor. And basically, we get the transistor to power this instead, because the transistor can handle it. So we get the microcontroller to control the transistor, and we get the transistor to control the relay, and then it will work. So inside the relay there's a coil, and that's the symbol for coil, or something like it anyway. And you power the coil here, so we have 5 volts here in this case, and this one goes to ground, or 0 volts or whatever. And if I just continue creating the relay symbol, it's something like this. So we've got, in my case, 2 possible connections, and we've got a common. So that's C for common, and we've got A and B. So what actually happens, when you power the coil, something happens, and basically an armature goes from B to A, and therefore powers the A circuit. And when you don't power the coil anymore, the armature moves back over to B. And that's basically how the relay works. And as you can see here, it's isolated. This means, well, it doesn't really matter what it means. You can see that the control circuit is not connected to the switched circuit at all. Anyway, that's one of the cool things about it. So it doesn't matter about the voltage or anything like that here. Anyway, so if I get to the problem, we power this with 5 volts here, goes to ground here, no apparent problem at the moment. But what actually happens is when you power this thing, you get a magnetic flux which builds up around, and it takes a few microseconds for it to build up, and it gets bigger and bigger until it's saturated, until it can't grow any bigger. So basically it generates a magnetic field around it, and it resists changes in current. So if there was to be a change in current, what would happen is this would drop slightly and fix the current problem, and when the current builds back up, it will make the magnetic field back to its full strength, if you like. So that's a cool thing about coils, but anyway, I've got off the point slightly. So why is this a big problem? Well, when you switch it off here, so if I just delete this here, hang on a sec, if I rub this out, let's add a switch here, let's pretend there's a switch, and that goes to wherever. When we open the circuit, what happens? Well, the magnetic flux here resists changes in current, and what happens is it collapses to start with. So if I just delete this, it collapses a little bit, and as it starts to collapse, it starts to induce a voltage into the circuit, and the more it collapses, the more voltage gets induced. So if I just delete this, so yeah, we've got a voltage already, we've got a bigger voltage, and now we've got its full potential voltage that the inductor could induce, if you like. So yeah, basically the energy that was stored magnetically gets converted back into electrical energy and forced through the circuit. And now it can't go through the usual route here. It can't. One of the reasons is because it's open. It can't, well, potentially it could arc through that, but usually it doesn't. So it can't go that way, and what actually happens is it creates a massive negative voltage. So it actually runs this way. Well, it'd have to anyway, because obviously it's open there. So it goes through here, and it goes through your control circuit, through your Arduino, through your ESP32, whatever, And the voltage that it creates, if I attempt to show you on a graph, hang on a sec, if I just get rid of all this, the voltage that can get induced is ridiculous. So if we have 0 volts there, and we have 5 volts here, when you open the circuit, or in other words turn the coil off, it goes like this. It could go way over 100 volts and then it kind of bottoms out. So yeah, this current, or this amount of voltage, is enough to ruin your devices. And basically, you can't allow it. We can't allow this problem. And in our case, what it would do is it would go through the transistor and probably blow the resistor, and possibly it could do more damage as well. It's certainly far too high a voltage spike for us to be working with, if you like. Anyway, so that's the problem, and in a sec I'll tell you how I'm going to solve it. Okay, so how are we going to fix this problem? Well, I'll just draw the coil to start with, and this is plus 5 volts over here, and presumably this is ground, but of course there's going to be a switch there. Not that it matters for the sake of explaining, but there's a switch there and ground. So how are we going to fix this problem? Well, we're going to wire in a diode, and this diode will help us to prevent the spike, huge voltage spike. So I'll show you why now. To start with, it doesn't look right, does it? The polarity of the diode doesn't appear to be right. So if you look at it over here, 5 volts travels across the wire, but it can't go down here because it's reverse biased. It can't go that way. So it has to go down here, which basically means that in normal operation, if that switch is closed, the coil will be powered. So this whole thing here, this diode, won't do anything. However, if the diode, no, not the diode, if the coil is not powered anymore, in other words, that's opened, something different happens. So I said earlier that a huge voltage is induced, but that huge voltage is negative biased. So here it could be, maybe, it could be 120 volts. It could shoot up to that if we were not to snub it in some way. But actually, with this diode in place, it would never get to that. It will go like -1, -2, -3, and then over here it will be balanced out automatically. So I'll try and show you how. So if we say this was -1 here, and obviously here is 0, what happens? Well, because there's a potential difference, then some voltage or current will flow through the coil and go through here, because now it's forward biased. If you look at it, that's minus, not 0. Go through the diode, and in fact the diode wasn't -1 volt wasn't a great number to choose, but anyway, I'll explain anyway. So here has a higher voltage, so it goes through and goes to here, and the magnetic field collapses a little bit. So then it repeats again, it goes again. As this collapses, it goes again, it goes round here, and it balances out again. And this reduces further, and further, and further, and further, and all the time, basically, current or voltage goes round and round and round and round and round until this is completely gone, magnetic field. So basically that's the solution, that's what we're going to do.